So, for your homework, one of the questions was question 11 from exercise 11C. And it's got a triangle, and it says, shh, triangle PQR. Can we stop the talking now? And it says that PQ is equal to 4i plus j. So I'm actually just going to write it as like this for PQ. And it says that PR is 6i minus 8j. The first thing it wants us to do is to find the angle QPR. Okay, there are going to be some things we could do in the future. There are some different ways of doing this. But at the moment, the way that we probably go about doing this, what technique could we possibly do to try and find out this angle that we've got here? Yeah, you could split it so that this is like the x-axis or the I component. And actually, we can just find out the angle that it makes here, PQ makes with it. Then we can find out the angle that PR makes with it, and then we can add them together. So if we just concentrate on the PQ part to begin with, we know that this is 4, 1, meaning it is going 4 across and 1 up. So if I want to find the size, let's call this one alpha, how do I find the size of alpha? Good, I do that alpha is the inverse tan of 1 over 4, the opposite over the adjacent. And the inverse tan of 1 over 4 is, I've just put my calculator away. Pardon? 14.03. Shh, guys, why is there so much mumbling? And it's from this table. There's lots of it from the girls' table. And then the other one that I've got. Huh? Then the other one I've got is PR, and I'm going to find out the angle that that one makes, which I might call beta, which is the other letter we could use. And it is 6 across and 8 down. But even though it's going 8 down, I don't need to write minus 8 because it's already being shown on my diagram that it's going 8 down. So beta, using SOHCAHTOA, would be the inverse tan of 8 over 6. And what was the inverse tan of 8 over 6, Hassan? We haven't done that bit. 53.1 sounds about right. Was this definitely right, the inverse tan of, is that correct, or shall I check it? Yeah. It is? Okay, good. So 14 point. Good. So this angle here, this is alpha, this is beta. The one that they want is angle PQR. So angle PQR is alpha plus beta, 14.03 plus 53.1, which is 67.1 degrees to 1 decimal place. That's what part A of the question said in question 11. It then went on to ask us to do something else. It went on to ask us to find out the area of this triangle PQR. And it did put a little hint. You should always read those hints at the side. The hint, it said, was a half AB sine C. You should remember that from GCSE. If you don't, we will be recapping this when we go through that topic a little bit later on. So for that triangle, I now have the angle is 67.1. What 2 things do I need to find out then? I need to find some magnitudes. I need to find the magnitude of PQ to find out this length, and then I need to find the magnitude of PR to find out this length. So PQ, its magnitude, how do you find the magnitude of 4, 1? 4 squared plus 1 squared, root 17, and the PR, 6 squared plus 8 squared, which is 10. So we have that the one at the top was root 17. It's a shame I wrote root 10. Root 17 and 10. So the area is just a half times 10 times root 17 times sine of 67.1. 19.0 units squared. So I quite like this question because it doesn't tell you what to do. You have to think, okay, well, I know how to do these things. I'm going to see how I can put all of this information together to be able to come up with that. If you've got any coats on or anything, I know it's a bit cold outside, but it's quite warm in here, so take your coats off and stuff. Otherwise, it looks like you're about to get up and just leave straight away, okay? Okay, so we are going to continue with what we were doing with vectors, and we're going to be looking at how we describe things, the positions of things. That sounds a bit weird, actually, to describe the positions of things, because I felt like that's what we were doing before. But vectors don't describe the positions. They are actually just a line segment that is floating around somewhere in space. If I say the vector 4i plus 3j, all I'm saying is 4 across and 3 up. I didn't say where I was starting, okay? I didn't tell you that it was starting at a particular point. So for position vectors, it says here, suppose we started at a point 3, 2 and translated by the vector 4, 0. Well, this thing that we've got up at the top here is not a vector. This is a point. What word do we use to describe a point? A coordinate. So we've got a coordinate and we're trying to translate it by a particular vector. And you might think that we could do something like this, that you have a starting point and you add a vector to it to get a finishing point. But the problem is that you can't add vectors to coordinates. It says down here, only vectors can be added to other vectors. If we treated the point 3, 2, which is just a coordinate, if we treated the point 3, 2 as a vector, then this solves our problem. Instead, we can just say we have our starting point 3, 2, we're translating it 4 to the right, and we end up with 7, 2. So our solution there is actually being used to change a coordinate into a vector. Nothing that crazy, but it's just worth noting that subtle difference between a coordinate and a vector. So this is a visual representation of it. This A that we have here, the coordinate A, can be written as a position vector, and we would underline that if we wrote it, 3, 2. It is describing its position relative to the origin. As soon as something is a position vector, we are saying, how do you get from the origin to that position? So it says, a vector used to represent a position is unsurprisingly known as a position vector. A position can be thought of as a translation from the origin as per or above. So it's saying from the origin, go to that point up there by moving 3 along and 2 up. It's just a translation. It enables us to use positions in all sorts of vector and matrix calculations. Matrices is something that you either do in further maths, or if you ever do anything like engineering or computer science, you would do those kinds of calculations at university. So the position vector of a point A, a capital letter A is used to say that it's a coordinate, is the vector OA, where O is the origin. OA is usually written as just A underlined. So you don't actually have to say that this position vector is OA. We can actually just say that it is the position vector A like that. Okay? We're going to try and explore some patterns now that happen with these position vectors. So I've got this diagram. It hasn't printed quite as clearly as I wanted it to on your booklet, but you can still see roughly the grid. And it says the points A and B have coordinates 3, 4, and 11, 2, respectively. Find in terms of I and j the position vector of A. Okay, so there's nothing really challenging there. The position vector of A is just 3i plus 4j. It's just telling us that to get to A from the origin, you move 3 across and 4 up. It's like right back to primary school. And the position vector of B is going to be 11i plus 2j. Just note that you could have done these as column vectors. We could have written them as 3, 4, and 11, 2. I have a preference for the column vectors because they are easier to calculate with. The reason I did I and j here is because the question was pretty fussy and said we want it in terms of I and j. If it says that, do it in terms of I and j. You can change it at the end. We now want to find out what is the vector AB. So I'm going to draw some things onto the diagram here. To find the vector AB, well, this is the position vector A. I might need to use a straight line for this so that I don't make a mess of my diagram. Let's put this in blue as well. This is the position vector for B, and we're trying to find out the vector AB, which I might just do in a different colour here. So we know that's the position vector of A, this is the position vector of B, and this thing that we've got in red here is the vector AB. How do you go from A to B using the blue pathways? How do we go from A to B using the blue pathways? Good. You go minus A plus B. The vector AB is minus A plus B. Now, more commonly, it would be answered in the way that Ishraq just said. The most common way that you will see AB is B minus A. And it will always be the second position minus the first position. So for example, if you had FG, it would just be G minus F, okay? You can now quote this. This now just becomes something that we can use for any two positions. To go from one of those positions to the other one, it is just the second position minus the first position. This should remind us a little bit of when we were finding the distances between 2 points. We found the difference between them, and that's actually what we were doing here. So let's actually calculate that. AB is B minus A. Well, B is 11.2, and A is 3.4. So we get 8 minus 2. I'm quite happy to leave it in that form of 8 minus 2. I want you to tell me, though, what is the significance on my grid of 8 minus 2? What is the significance of 8 minus 2 on my grid? How does 8 minus 2 link to my diagram on that grid? Yes? From A to B, we make a journey of 8 to the right and 2 down. Let's just double check that that works. Obviously it's going to work, but we'll just check. Actually, we're going to go 1, 2, 3, 4, 5, 6, 7, 8 to the right and 2 down. That's actually what's happened there. And if I wanted to find the distance AB, well, I know that's 8 and that's 2. I could just do the magnitude. I could do 8 squared plus 2 squared and square root it. Okay? So, this little bit that I've put down here, 4 position vectors A and B. The vector AB is OB minus OA, but really the vector AB, this is the thing that you must have committed to your memory. AB is B minus A, the second letter, take away the first letter. Not only will you use this in this topic today, you will use it when you do mechanics with me. You will use it in year 13 when you do vectors. You will use it in year 13 when you do loads more mechanics. It is something that will get used very, very frequently. Further mathematicians, we will use it when we do vectors in further maths as well, because we do quite a lot of work on vectors in further maths too. Okay? Now that we know that AB is B minus A, we can do lots of other kind of problems using this as well. Can I go on to the next page? So I'm going to just do a few questions here, and then you've got a few questions that you're going to do as practice for me. So we have A, B, and C have these coordinates respectively, and O is the origin. First thing it wants us to do is find the position vectors of A, B, and C. Okay, well that's pretty boring. The position vector of A is just 3 minus 1. The position vector of B is just 4, 5. You can see I'm just taking these from up here. And the position vector of C is minus 2, 6. Pretty simple. We've just grabbed the coordinates and we've changed them from coordinates to position vectors. That covers that first slide that we looked at. Then it wants me to work out what AB is, which is just B minus A. So that's 4, 5 minus 3 minus 1, which is 4 minus 3 is 1, and 5 minus minus 1 is 6. So there's our vector AB. I also want to find out the vector AC. Saeed, what would the calculation be to find out AC? Good, it would just be C minus A. So now I'm just going to put in the C vector, and I'll take away the A vector. And what should these be? I've got minus 2, minus 3. And then 6 minus minus 1. Good. So we have 5, 7. That's the whole of part A done. Part B of the question wants us to find in third form OC with those lines around it. What do those lines mean again? Magnitude or modulus, size of it. So OC, well, we don't actually know what OC is, or do we know what OC is? From the origin to C. So it's also the same as the magnitude of just doing C. And the magnitude of C will be 2 squared plus 6 squared square rooted, which is root 40, which is the same as 2 root 10. Then it wants me to find out what AB is. Does anybody remember what I said AB with the vector sign on it and the modular signs, what that's the same as? How else you could write AB with this and this? Not the hat, the hat's a unit vector. It's just the same as AB. Because this is the AB vector, and the modular signs are turning it into a length. So I could have just written the length between A and B. These two things mean the same as each other. Okay, I just thought it was interesting to point that out. So all I'm going to do is take the modulus of this, which will just be 1 squared plus 6 squared, square rooted, which is root 37. And then I'm going to do the last thing it wanted for me, which is AC. I could say that that's the same as AC, but it doesn't really matter, so I might not do it this time. And that's just going to be the square root of these bits added and squared. 5 squared plus 7 squared, 25 plus 49, 60, 74. Is that right? Yeah. Root 74, okay? Nothing really new other than the fact that to do these, second letter take away first letter, every time. So, can I start the next example? Yeah? We've been given two pieces of information here. We've been told that OA is equal to 5 minus 2, AB is 3, 4, and we're going to try and find the position vector of B. There are a few ways of doing this, but I perhaps would start off and I would take some of the information from the question, I would take this and I would write it out. I'm going to say that something is 5 minus 2. What do you think my something I'm going to write there instead might be? Yeah, I'm actually just going to write A, because I know that from the origin to A is just the same as the position vector of A. And I've also been told that AB is 3, 4. And I want to find out what B is. But I know some sort of relationship between A, AB, and B. I know that AB is the second letter, take away the first letter. So AB is 3, 4. That's equal to B minus 5 minus 2. Yeah, I'm going to add this vector, just like I would solve a normal equation, I'm going to just add this vector to the other side. So I'm just going to come up here. I then get 3, 4 plus 5 minus 2 is equal to B, which tells me that B is 8, 2. So that was one of the ways that we could solve that. Once you finish writing that, I'm going to show you a different way that you could imagine this question, okay? The different way that you could have done this part over here is we could have thought about the geometry of this. What does it look like when you draw it? That's what I mean when I say the geometry of something. What does it look like? So I've been told what OA is. So if I call that O and if I call that A, I know what that journey is, and we called it A. We've also been told what the journey AB is. So there's B, and I know what this thing here is. It's AB. The thing I'm trying to find out is the position vector of B. I'm trying to find out what B is. Using this triangle, what is B equal to? Yeah, to go from O to B, it's the same as going A plus AB. A plus AB. And look, this is what we've said. B is equal to A plus AB. B is equal to A plus AB. I don't know which way you prefer. I definitely know the way I prefer. The way I prefer is the first one that I showed you, because it all relies on, have you remembered that AB is B minus A? As soon as you've got that, it's just solving an equation. It's dead easy and it's super simple, okay? So you've now got on the bottom half of that page, there's not an awful lot of space there, so if you're going to do it on the page, you need to write it nice and small. This is pretty straightforward questions, so I would like very, very quiet for us to do these ones. And we'll spend maybe 10 minutes answering these. I'll leave this up on the board, but these are the questions that you're going to do here for me. I'll also put the answers up a bit bigger so you can check them as you go. Okay, you may not have enough space to do it on the page, but you may do.